I'm going to start by talking a bit about myself and why we're having this session. Oh, there's Matt. So, I've been a Drupal developer for practically 10 years now. And I've been working with Drupal 8 almost 3 years. And there was one subject that I felt I had no control over, and it was the entities and the TypedData API. So I figured I'll give myself a challenge, give a talk on it, let's people can. And that'll be my motivation to go in depth and figure out how all the pieces work. I figured if I'm struggling with it that much after so much time, I'm sure other people are having trouble as well. So thank you all for being in the audience. But who are you guys? What's your level of proficiency in Drupal? What do you do? Can someone raise their hand?
Drupal developer.
Yeah. Is anyone not a developer? So everyone here is a developer and has a lot of experience with Drupal. Like, have you all worked with Drupal 8? No. So for some of you, this is your introduction to Drupal 8. Okay. Well, this was my starting point actually, because if you've worked with Drupal 7 entities, you're used to seeing something like this. Probably it's invisible if I highlight it. Sorry. But if you dump an entity in Drupal 7, you get a standard class object. And it has a bunch of properties. You get your type, your status, your fields, and it goes on and on and on forever. And in Drupal 7, we were pretty used to just dumping the entity using Devil or whatever tools we had, looking at it, changing the values, and saving. The problem with that is that the language itself and the application has no idea what this data is or this entity is. So if you ask PHP, what's type on this entity object, it's going to say, well, type is a string. Of course. What's status? It's an integer. What's created? Well, that's also an integer. We know it's not an integer because we have outside information about the API and what these parameters mean. But there's really no way to manipulate it that's stable and safe. So it was very difficult in the Drupal 7 world to create tools around this destructured data that we get in Drupal. And so, we had the metadata wrappers. Have some of you worked with that? Yeah. This improved things a lot by creating an interface. We could get fields, set them, and save entities without reading an external API. We had everything in that API. But still, this wasn't sufficient because in Drupal 8, we were even more ambitious about what we wanted to do with data. The successor of this system is called TypedData. And it's behind almost everything you have in Drupal 8. It's just hidden at such an, how can I say, basement level layer that we don't know it's there even though we're dealing with it with almost everything we do. Oh. So I'm going to do most of this presentation inside the Drush PHP shell because it allows me to do live coding in a way that's robust and visual at the same time. And I don't really mean for this to be a linear presentation. Like, I'm going to be honest with you, I've rehearsed only some of these commands. So if at some point you have any question about what I'm doing, please interrupt me and ask a question. We'll go over that topic. So almost everything we're going to do for the rest of this presentation is going to be around a basic node object. So first I'm going to create a node object. And the only part of data that you need to create a node object is the node type. It's going to be a basic page. All right. This is my node object. It has no data at all, but it already has a bunch of fields. And those are its elementary type data parts, so to speak. So if I were in Drupal 7, I will say, okay, I want to see what's in my node. I'm just going to dump the node and look at its properties. And what was that? Oh, okay. And now I'm very sad because nothing here is useful in any way. Because the whole entity API is now object-oriented, which means we can't really dump anything without getting all the services that are referenced in all the objects. And the entity objects are the maximally complex objects in Drupal. So this is going to get us home. Let's try the most basic manipulation of the node. If we can't explore what it is, I'm just going to look at one field and see what we can do with it. So let's go with the title. Title is a very simple field. So I can access the title just by calling node title. And I get another kind of object, which is a field item list. Okay. Does it make sense for a title to be a list? I don't know. But I can't just assign things to it. I think it's a protected property. I'm not even going to try because this API is held together by magic. But I'm going to try I think this is possible. No, it's not possible. Okay. I'm going to try to see what class this is. So we know that field item list is the class of the object. But can this? Oops. This will happen a lot. All right. So the field item list has two class parents. The item list, which has nothing to do with the field system, but is part of the TypedData API. And it has TypedData, the object itself. So now we're getting somewhere. I still don't know how to set my title, so I'm going to go one level deeper. I'm going to try to use the node API to set the title and see how this affects the data on the node. Okay, so now I got my node back, but what about my title? Oh, now there's a string item in my field item list. What's a string item? I don't know. It's a field type. But I'm going to put the value. So the value I set for my title is encapsulated inside an array called with a property called value inside the property value of string item. So now I'm getting somewhere. It's a lot more complicated than what I had in Drupal 7, but I can see my data. Let's see how many parents this class has. Okay, so string item base has as a parent field item base, the map data type, and again type data itself. So we found out that type data is used to encapsulate more type data. And that's the first lesson about the object-oriented system of Drupal 8. There's this debate in programming about whether we should compose or inherit classes and data. Well, in Drupal we decided to do both. Type data is a system that's both based on inheritance and composition. And all the data Drupal 8 relies on both of these principles at extremely complex levels. Okay. So now it would be interesting to find out just how many classes rely on type data based on what we've loaded so far. There's a little script here that finds just that. Okay. Let's sort these. Okay, this is every class that's been loaded so far in the system that's a subclass of TypedData. We have some that are relevant to entities, some that are relevant to fields, some that are plugins of fields, some that are elementary type data types, who knows, and some that are relevant to the text module. So at this point, I think it's better to go and have a look at the classes and see just how deep does this inheritance go. Is everybody following me so far? Okay.
Yep.
A good place to start, type data class, is go see just how many subclasses are involved here. And there are a lot. So this is not going to get us very far. I tried to produce a nice diagram of the type hierarchy around type data. And I gave up after a few layers because there's just too many. So feel free to explore that for yourself. I don't think it's a very fruitful investigation. But we can look at the class itself. Since it's behind everything, its interface and its methods are going to be found everywhere. So they're a kind of universal interface to data in Drupal. So what do we have here? The abstract base class for type data. Classes deriving from this base class have to declare value or override get value or set value. So that's interesting. That means we can use get value and set value on practically everything we see in Drupal. It always has a data definition. This was a subject that brought people to this session. And the data definition of type data is the description of the type of this data. We're going to see later how to use this to create, for example, validation. It's a property name. In most cases, it's just going to be value. Sometimes you'll see something like format or something. Target ID often for more sophisticated things. And a parent if it's part of a deep hierarchy, if it uses composition. Okay, so we have get value, set value. So, how do we create a type data object? There's a type data manager in Drupal that handles all of the object creation methods and factories. If I go back to my demos. All type data objects, which are, again, maybe I skipped this part, but type data objects are just regular PHP values with a class wrapping them. But in order to create them, we need to declare to Drupal that there is a primitive type or a more sophisticated type that we can create as a type data object. And this is done using plugins. So I'm going to cheat a little bit here and see if there's elementary type data that we can do. Let's go with an integer. It's a field. Okay. So we have integer field and integer data. Let's go with this one. All right. The integer data type. The plain value of an integer is a regular PHP integer. For setting the value, any PHP variable that casts an integer may be passed. Okay. So let's go in our terminal and see. Can we create an integer type data object? First, I'm gonna call my type data service.
So there is a service?
Yes, there's a type data manager that creates all this stuff.
What do we need it for?
To create stuff. Let me show you.
Okay.
All right, so as I was saying before, the data definition is the metadata that describes what kind of object you're going to get. And in the flow of creating type data, you first have to create a data definition, and then you can create an object in which you can inject your values. So in your interface of your type data manager, there is the create data definition method. And this was called integer, right? Yeah, okay. This takes the annotation ID of the primitive data type plugin that you want to use for your final type data object. And each of these primitive data type plugins will usually also define a data definition, or if it does not define a data definition, you'll end up with the default type data definition object. So I have my data definition. I can manipulate it in different ways. No, that's my service. Hold on. Start this definition. All right. Okay. I can ask what the properties of the data is, or I can modify it in order to affect how the data will be used later on. For example, I can declare that it's compute, or actually let's set as read-only. It's computed, it's another topic. Okay, and I get the object back. It's also chainable for this reason. Let's also set required. Right. Okay. I get my definition object built. Let's try to see what its contents are.
So set required means it can't be, it can't evaluate to false, is that correct?
It can't be empty.
It can't be empty.
Yeah, but keep in mind that everything that goes in the data definition metadata is not really enforced by the type data classes. It's only available for you to inspect. So we're going to see later on how this affects our development. So now I have three properties, all right, but I still don't have any object. But now that I have this data definition, I can use my manager again, pass the definition, and pass a value. Let's call it string 1. Now I've created an integer data type. Call it my integer. Okay. So now we have a regular plain type data object to play with. What can we do with this stuff? Let's look at the interface. Okay. The class methods include some things that are relevant to the Drupal 8 plugin system, but there's also a lot of very interesting methods to manipulate objects. Let's start with the universal one, get value. Let's return string as 1. But really, we created an integer data. We don't want string. Fortunately, there's another method that's specific to these primitive data types, get casted value, that converts it to the proper type. So if I go back to my integer data, get casted value is its only subclass method, and it just converts to an int the value of the object. What else can we do with this? There's a very nice method called validate. Oops. What is this? Oh, my SQL server has gone away. Sorry about that. It's gonna happen. If few times. What do I want to replay here? All of it really. Okay, so it still works. This is what crashed. Okay. All type data objects have the validate member method on them. And this is how you check if the content of the type data is actually good. It won't stop you from setting values to anything kind of weird or goofy. But you can tell if your object will save to the database properly. So we don't have the problem that we had in Drupal 7 that we create a node object and then just try to catch all the database errors when we tried to save it because we didn't know if it was good or not from the object itself. Now we have validation, and validation is hierarchical. So that means if I call validate on a field item list, it validates all the items inside it and validates all the properties inside the items inside it and so on. So let's look at the violation. Did I have any validation? 0. Okay, so my object is good. But would I have any violation if I had no constraints on my data? Well, there's one way to find out. From my type data, I can get the data definition that I used to create it, called get constraints. Oh yeah, there are 2 constraints. It needs to be a primitive type and it cannot be null. So let's try to fail those constraints, see what happens. I'm gonna call set value. And now I'm gonna put, alright, so it still lets me do it. But I'm going to validate. Now I have 1 violation. So what can I do with these? You can just get the iterator or get the, let's get the, so that's a validation. Get message. Okay, so those are Symfony framework violations. So it says this value should be of the correct primitive type. So I failed one of my 2 violations. What was the other one that did violate? Not null. Oh, interesting. Let's try to fail that one. Right. This value should not be null. So, this demonstrates how to use the validation system on the most elementary parts of type data.
How would you make a custom validation? Like, for example, it has to be higher than 0. You have to create your own validation class at that point and add it there.
That is a good question. Let's go see how it's done for integers.
Just one question before you see that, like, those validations are done automatically, right? On nodes, for instance. Before node save, for instance. Like, you create a node and you call a node save. Is the validation done automatically already?
Let's try. It's going to be my answer to everything today. Do I still have my node? Display all 907 possibilities. No, I don't. Okay, so create a node, let's save it. Well, it worked, but was it valid?
Well, you should not, because you don't have type,
Because
right?
zero does not exist. So I had no violations on my node. But I should actually make one with a violation. So let's go back to the node level here, because we've been at the very elementary primitive types. Let's go back to the integer type, where everything is complex. I'm going to recreate a new node. Oh. Professional coder at work. Okay, so now I have a node with just a type. And if I save it, whoa, no, apparently you're wrong. Because it went straight to the database.
Yes, if you validate it first, then it's going to. Okay.
If I validate it, I'm going to get an entity constraint violation list. And is there a violation? Let's count my violations. I have one violation. So let's see what that is.
So yeah, just have one question before we go to custom validator. I'm still struggling to understand why don't we catch this then, in Drupal. It just raised those crazy exception, it breaks the full application, most of the time. So I just want to know, as we are saying it live, there is no way to catch it and do not crash everything and do something with it, like on not safe, for instance.
I think I'm just guessing here, but because the validation system is deeply integrated to the entity form system, in the way that when you call save, it validates, and the property path it gets back is what gets highlighted in the form, we've decided that there was no point validating again on node save. They assumed that developers wanted the freedom to do things separately in the order they wanted. So I did get a violation error on my node. Let's see. No, this is a message. That's not going to work. And I want to know which property was affected by it. I have get property path. So the title was the source of the error. So validating the entity would have told me that it could not be saved.
It's true, sometimes if you want to save nodes without titles, it can happen in certain use cases.
No, you have to put an entity title.
Yeah, but
Not the null
I
title.
understand the reason why it's not validating necessarily always. They might intercept an empty title and put the word empty instead. They don't want to validate it first. I think it's a design decision to not make it validate automatically.
Yeah. So your question was, how do you create a validator? The integer data, I don't think, has its own validation. I don't know where its validation came from, to be honest with you. It came from a magical place. But typically, no, let's go to primitive type. Okay. Let's say we have a duration here. Data time duration. So, no, it's not validation. Might have to go to something more complex. Email. All right, email. This one has defined constraints in the annotation. It says the constraints is email. You have to look in the documentation to interpret that, but it's actually a Symfony constraint. So it's part of Drupal core validation. It's annotated as a constraint. So if you add it to your custom data type using the annotation idea, you will automatically get this validation. So it's validated by the constraints email validator. What is this? Validate. It can be null and probably some formatting to make sure it's email. Oh boy, it's complicated. So we have access to the whole library of Symfony validators in TypedData directly. But actually, I think they have to be bridged by these Drupal objects, email constraint. Oh, because of the annotations. So Drupal won't detect automatically all Symfony validators unless they're decorated or wrapped by annotated objects.
And you need the constraint and the validator to need the two of them, two classes.
Well, you can create your own constraint that doesn't rely on a validator. You just generate your own validator. I think I might have done that at some point. I completely forgot. Okay. So
Can we extend somehow the annotation? Like, for instance, I implement a validator to for something like the field can be empty, but on a specific node type with specific rules, and so I had to redo the logics inside the class. So maybe somehow we can extend saying that validator only happens. I don't really know. I wish I could have parameters in the annotation, so I don't have to type down all the logic. If that's what you think is possible to extend that.
there's something called complex data validation. It's present on some of the field types. So let's start exploring field types. So we created a basic data definition, and where's my IR key here? So we have the definition. No, it's something else. So, definition. Base. Go on to the base field storage, field item. Let's explore a field first, because that's where all the complex validation is going to take place. So, go back to my node. Okay. So we were working with the title. Node title is a field item list, which was part of TypedData, and it has its own data definition. Alright, which is called the base field definition. The properties are on this base field definition. Oh, all the field properties, interesting. So, are there constraints on this one? Constraints. Oh, not null. It's the only constraint on the field. So let's find out what this looks like in the code. Let's go back to the node. Each entity in Drupal will have this base field definition static method. And what this does is generate the data definitions for the properties of the entity. Not for the fields which are created with configuration. This comes from another method. This is really the base properties. Each node type always has a title, so this goes in the base field definition. So when the TypedData manager tries to create an entity, it will ask, what are the properties of this entity? So the title property is a string of type base field definition. And then once you've created your data definition object, by calling its createSelect method. Then you can set its properties. It has a label, it's required, it's translatable, revisionable, it has settings, and so on and so forth. So the most important part of this segment is the value of the create method, which is the ID of the data type that you want to create with your data definition. So it's going to create field item data definition with this type. Okay, let's try and do it directly without going through node entity. So this is the field item string. So I add my type data manager. Yeah. Create data definition, field item, and this was a string. Right. I've created a field item data definition using only the type data manager and the identifier of the type data item I want to create. And this is completely equivalent to what's on my node. So let's call it my custom title object. Right? So if I call get value, I will get nothing. Oh no, okay. What's the problem? No, it's just a data definition, of course. Sorry. I got confused. So the data definition, it just lets you, for example, get the constraints. So it has no constraints at this moment. So a pure string object doesn't have constraints, but the title object does have constraints. And here, we don't see this, only that it's required. So this set required is probably the source of its constraint. So there's no not here. Let's go find what this string field is. String base field. Does it exist?
So remind us, why do we need so much classes then? Why do we need so granular thing?
I stopped asking these why questions. I just go and look how and not why. The how is what matters. Okay.
Yes, maybe there is a good reason I don't know it. So,
Okay. So when I called my type data manager with create data definition field item string, what it actually did was look up at this field type, which is a string, and it extends string item base. This actually does have constraints, so I didn't get the right thing. Okay, string item base. No, I got the other one. What am I looking at? There's no constraints. Okay. So I created a string field item to the field item data definition. It should have the constraint. Or I'm looking at it the wrong way. I have to create my object first. Create. This makes no sense anymore, but it's okay. Foreground and beginning. Yeah. Alright. Okay, now I have a string item. There you go. Those are the constraints. So this is called a complex data constraint, and what it actually does is loop over all the properties of my field item, which is a string item, and apply different constraints on different properties. So the value property has a length constraint, and it says that the maximum number of characters is 255. And the character set has to be UTF-8 because that's what we need to validate things for our database, for instance. This is provided by getConstraints here, the method. So there's a constraint manager that created the complex data constraint and passed these constraint parameters down. Matt, does that help you with your constraint creation issue?
Yes, so you have to do it in the class base.
Right. You can use annotations or use methods of the class as well. There's not much time left. Alright, so let's try to get back on track here. So we've looked at it from the leaves of the tree, the primitive data types, from the root of the tree, which is the entities. Let's try to go a little bit oblique here. So one thing that the TypedData API provides us is the map base type. And map, let's go straight to the map class, is almost as big a base class as TypedData. Everything is based on a map. Every field type in Drupal is a map, which means it's just a key value paired array of data. And most of those fields just have one property in that key value paired array, it's value. But map provides the base interface of all the fields. So it has a getter on the property name, it has an iterator to go over these values, and you can get the properties. But it also has the regular get value. So, let's not go there yet, that's for later. If I go to my string object, and I for each it, can inspect what keys I have. Its value in this case. Oops, well the value is a type data, so I shouldn't have done that. So it means that I can use get on the value and get another object. And that one is another primitive data type. It's no longer a map data type. So in my field type data object, there's another type data object under the key value, which is a primitive type. Which is why we need the complex constraint system, because we want to apply constraints inside an existing object. Okay, so we got the value. What's next? String data. What was in my nothing. The same interface is available for us in all type data objects. So let's try something here. So map objects have the set property, and you can call set with the key and provide a value. List objects also have the set property, but you have to pass an index to set or an append item. Okay. So I have a string, I've set its value, it's now a string item. Where's my stuff? It's gone. Okay. So we've seen what classes are type data. We've used the type data manager. We could look at the serializer, but I wanted to look at computed class first. So let's go back to the node object. The node has a title, we've gone around that. The title is a string field item type data object. It also has a UID, which is an entity reference. But the nodes we've created right now, we haven't set the author, so I won't go there. I'm going to look at something else that's of interest, which is on the content entity base type, editorial content. That's the new thing. Base field definitions, all right. TTKSKey bundle, all right, so let's go back to the node. Node as a type data object, which is an entity reference field item list, and it has an entity reference item on it. This is, by the way, equivalent to, can I do this? I hope so. Yes. Getting the same object in each. So, on my node, there is an entity reference item with a value target ID page. So, let's call this the node type. My node type, on account of being an entity reference item, has computed properties. Let's see if I can get the properties from it. Yes. Okay, target ID, so I can't get the computed properties. Can I get the references? No, it's not on this one. Or it's a string data. I get entity, but I don't want to do that. Let's inspect the definition. Fill data definition. Okay, so I do have the entity property on this object, but it's only available if I go through the data definition of my node type field. So let's see what happens if I hit the entity property. Oh, I just loaded a completely different node object. Let's call this. Okay. This was done by the magic of computed fields. So the bundle has an entity reference type. And entity reference is a very important base type because practically everything that relates data to some other data in Drupal will have an entity reference as the base field definition. Let's go to entity that exists as a quantity plugin data type. Right. Data reference. Is this the map type? Yes, the data type. Right, it's a data type of entity reference. But there is also a corresponding field type. I hope some field. T-reference field item list. T-reference item, there it is. Okay. So, entity reference field type has a much more complex property definition. So it has to switch if the target ID data type is a string or an integer, because we have two kinds of entities in Drupal. We have content entities whose identifiers are integers, and there's the configuration entities that have a string identifiers. So the node types, article or basic page, they are considered configuration entities, which is why they're kept in data as a string. Where was my target ID? The target ID for the node type was string data, but the entity was loaded because it was resolved as a string and there's another property on my reference field item, which is a type entity that is computed. So that means it does not exist on the object unless I call it, and then it will compute what the entity is. It has its own kind of definition, which is a data reference definition, which provides what kind of target it is and how to resolve it. So if I go back here, let's try to play around with this a little more. So we have the entity. Okay, field item data definition. Let's pass like this. Entity definition. Okay. So one is a data reference target definition, and the other is a data reference definition. But only target ID is a value. Entity is computed. So, trying to hurry this up. We remember how in Drupal 7 we could easily dump data. Well, Drupal 8 has its own new system for doing that called the serializer. I think this is it. No, it's not. Oh, it's not gone away yet. Okay, serializer. So, if I create a new node, can use the serializer to serialize my node. I think the format is like this. So let's try it. And say JSON. I can also use the serializer to try and convert it to XML. Okay. So far, this doesn't seem too magical. But let's say that I'm importing data from somewhere else. The serializer goes through an intermediate step, which is normalization. And this is just preparing content for serialization. So here's my node displayed as an array, which is something that would be compatible with the JSON encode. I can modify that. So let's manipulate the node this way. Okay. Let's change the title again. Do I need anything special on this? No, it's just an array. I think it's going to be valid. So now my normalized entity has a title with the value of title. Did I do this right? Oh no, I didn't do it right. It's a list of a list, right? It's here, but it's badly formatted. Let's try to deserialize it anyway. Not normalizable value exception with message could not denormalize object of type JSON. No supporting normalizer found. Is it just broken? No, hold on. Getting late in the day. What are you doing? Data type format. Oh, okay. This is me being silly. Apologize. Okay. So normally, I take my new node that I've normalized after potentially deserializing it from some external API. And I expect a title. I got my title. So I was able to manipulate the node as an array directly and then deserialize it.
So we one step in Drupal 7, now you have to do it this way.
Yep. Now it's much better.
2 steps instead of 1. But you get all that.
But you see the magic involved in this though. Because in Drupal 7, I wouldn't be able to validate data that's coming from an external API.
Yeah.
But now, because everything is defined as type data, the normalizer knows exactly how to transform data from one format to another. There are other formats we can
experienced
use.
a lot of problems with caching in normalized data. When I started using it to do API, to do like API responses, because Drupal has a whole system of determining which data is cacheable and cache is invalidated and so on. So as soon as you normalize something, it's going to throw an error if you try to expose that thing you normalized as part of a response to a call to something which should be cacheable. So it no longer knows that, let's say, a title needs to be cacheable because it's become just a string. So it kind of lost track of when it's supposed to invalidate that cache. And the error is really a very weird error that breaks the entire site when that happens. So as soon as there's anything that you rendered through a normalizer and you try to expose it to public in a cacheable way, it might break. I've spent lots of hours trying to debug that specific problem before understanding it.
So the lesson is don't go there unless you're brave.
That's the lesson.
Yeah. All right. So we have 0 minutes left, so I'm going to go right to my final point. I have my new node, my new title, do I? I think so, right? Okay. We can also render fields directly from these properties. So I want to see what my title looks like. Because it's part of the field item interface, I can just call view on it. And I get a renderable array for this part of the node. We can do some pretty funny manipulation of entities that way. Where's my file? I had this demo controller where I programmatically create a node and then output different fields in different parts of the page.
This is a really good example for if you're working with images, like I'm using this tool view with images. It's been a nightmare for many people trying to render the image. That's really useful.
Yeah, so it's an interface available on all the field item lists. And also the specific field. So here, I have a controller. It creates a node of type page, sets the title to my title, and then I'm going to generate 10 field items on the body, and append the value paragraph with the index. That creates a regular node. But then, instead of using the regular view builder of the node, which uses view mode and so on, I just want specific parts of the field one after another, specific parts of the node one after another. So I want the 4th element of the body field, on the title, and then I want the whole body field again. And what this looks like in my app is this. The 4th element of the body field, the title, and then the full rendered body field itself. So you can really go wild with how complex you want your layouts by directly manipulating your nodes. And that's all the content I had prepared. Any other questions that you want me to address while I have all my debugging tools open? I'm happy to oblige.
So one question, can we try to answer why is it done that way? Like, what's the benefit of having so many granular things? And why not just one? Because there is like the config and content entities.
Mm-hmm.
Then basically value field and entity reference field. Why do we need like 1,000 class between the basic and the final value? I just don't understand why. So it's obviously there is a good reason for that.
I feel that I'm only on the journey of appreciating this API, so
Okay.
I could give a reason, but probably would be the wrong reason.
There's been some debate also in the community about this, I recall. A lot of people are finding it a bit complex, and it's some developers have been lost to Drupal because of that, I think.
Yes, also the documentation says to be written.
Says what?
The documentation page has 3 paragraphs and then it says to be completed. So what I did to prepare for this is just go through the code, try everything, and also I had this PDF of a DrupalCon presentation from 2 years ago that I barely understood until after I learned it, and then the presentation made sense. So this is something you can go have a look at as a follow-up. All right.
And it's a real world use case for this, like normalization, external API, that's a good example for instance.
Well, the real world use case is Drupal itself, because everything I've shown you is just different intermediate layers of the Drupal system working. You can call them directly, but when you save a node from a form, you're calling all of them. It's just at a deeper level that you don't perceive.
Yeah.
So if you want to go hack in there, you're going to have to encounter the TypedData system.
You're dealing with everything you do with Drupal.
Yeah.
You know a little bit about it. Thanks for this, Brian.
Thank you for coming.